Hey, this is Step Amit. Welcome to my Exorcism.io series. In this video, I'll be working through the kindergarten garden exercise from the Exorcism.io Ruby track. So in this exercise, we're going to be given a diagram representing plants on a windowsill, I think it is here. And what we need to do is figure out which students in a kindergarten classroom is responsible for which plants. All right, so they're learning about growing plants, and they're growing grass, clover, radishes, and violets. They've got little cups along the windowsills, and they planted one type in each cup, choosing randomly from the available types of seeds. So there are 12 children in the class. Each child gets 4 cups, 2 on each row, so like this. The teacher assigns cups to children alphabetically by their names. So in alphabetical order, Alice, the first kid, so she gets 2 on the first row, which are V and R, violet and radishes, and then 2 on the second row, which are radishes and grass. And so you can see this is kind of what the whole thing looks like. You've got 2 rows, and in each group of 2 is 1 student. So like this VV goes with this CG here. All right, and that's how it works. Let's grab this and pull it down. Get rid of that default file there. Bring in my rake file that allows me to run my tests with the key mapping I've got set up in Vim. And I'll start a new TMUX session. Go ahead and open up the test file here and see what we're looking at. All right, we have got a file named kindergarten_garden.rb containing a garden class that we initialize with with a string representing our 2 rows of plants here. And then instance methods, it looks like for each kid. Okay. Ooh. Okay, cool. We're going to get to do some metaprogramming when we get down here because the student list is dynamic. All right, well, let's get started. I'm going to open up my test running pane down here and just run the test to start with, which will fail because I deleted that the Ruby file. So let me go ahead and create it. Kindergarten.garden.rb. Switch my panes here so that my tests are on the right. Run it again, and it's going to come. It'll fail because I need to initialize the garden class. Uninitialize constant. Yep. So let's just get started there. Garden. Next, it's going to want me to define an initialize method that takes an argument for the garden string. So what I'm going to do is create an adder reader here for my garden to hold the garden. Although I think pretty quickly I'm going to want to split that up into rows. Let's just start here and refactor as we go. Let the test guide us. And so garden. And then now it's going to complain because we don't have an Alice method. Okay. So let's define this. I'm just gonna define it now for the first few here and let that guide my implementation of method missing to handle multiple students or handle a dynamic list of students. So Alice needs to return something here. And I think what we're going to do, let's see, it's going to fail. I'm not returning anything here. What I would like to do, because we need to map these single letters to these symbols that represent the names. And so what I wish I had was something like this. Like right now, for this example, I only have Alice's plants here. So I could take garden, the characters from garden, and then I could map that. And if I had a hash containing that mapping, let's see, what would that be called? That would be called crops. Then I could do that. And I think that would return what I wanted. Let's just see here. Crops. So let's put it up here. Crops. And this is going to be C for clover, G for grass, R for radishes, and V for violets. I think that will make the first test pass. That should be enough. No. Because we have got this character in here, this new line character. For right now, I'm just going to compact this. We'll have to do something else in a second. Okay, so here we go. Test a different garden for Alice. That should just work. And test Bob's garden is going to fail. And this is where I think we might need to do something a little bit different here. Because we have, undefined method, Bob. Let's just let the test guide us. I'm going to copy and paste this, and you'll see it will fail. Bob. Because I'll return too many things. This will return everything. And I don't want to return everything. I don't want violets, clover, grass, violets, radishes, clover. I just want the second group from each row. So now what I need to do is actually split my input, my garden, into rows. And in addition to doing that, I need to get from each row the slice of that row that represents that student's plants, their cups with the plants in them, and then do the same thing that I've done here so far with those. So let's see. Let's see. So let me start with this split here. I'm going to take my garden and I'm going to split it into rows. Lines. But lines by itself will not get rid of that new. It'll keep the new line character on the end of the first row. So we want to chomp it. Chomp true. If we pass that to lines, that will do what we want. And so now, let's see. I want the chars for each row. So I need to actually map this, and I'll just do it here on the way in, to chars. And so now my rows will contain the chars. Let's see here. And so each row I don't want to map the row. I want to map the chars inside of the row, right? So let me just do this the simplest way to make it really clear to me. So for each row, I want to map. So this row is going to be an array of chars. I want to map that. I don't need the compact anymore because I've gotten rid of that. And I need to flatten that to a single array. I'm just gonna let me copy and paste this. Well, I mean, Bob is still gonna fail. Let me skip that one again and just see if this. Does this still work for Alice? Yeah, okay. Still works for Alice. Bob is still gonna fail because we're not doing what we need to do. Even if I copy and paste this, I'm just gonna start with copying and pasting. This is still gonna fail because now I'm back to the first problem where I'm returning everything instead of just what I want. What I need to do is I need to come into here and only get his. I want each row to be just his 2 cups, right? And so Bob is our second student. So Alice has the cups at 0 and 1. So what I need to do here is I need to start at 2 for Bob, and I need to take 2 cups. And that, I think, will be what I want. Yep. Yeah. So you see what I'm doing is map. Remember what map does is it takes map returns a new array that is the same size as the original array. And for each iteration, each element, you're given the row. And whatever you return from here becomes like the new element at that position, or the element at that position in the new array. And so instead of mapping the entire set of the entire set of cups for that row, I'm just taking the 2 that belong to Bob and mapping them to the crop names and then flattening the whole thing. And so actually, I can do this here for Alice as well. Alice starts at 0. Okay. And then I'm going to leave it like that, sticking to the rule of 3s, which says, you keep the first duplication as is until you know more. But the third time you split it out. So we need a Charlie here. And so what I'm going to do for Charlie is, well, let me just duplicate it first. And then we'll take out the duplication. And when we take it out, we will be well on our way towards the dynamic version using method missing, I think. Because you can see there's a ton of duplication in these. The only thing that's different is this starting index. And so if we had a private method in here called planters from a given column. So with a start index, start column, then that could do this. And this would be start column. And so I can test this from taking Charlie here and calling planters from column with 4. And then same for Bob with 2. And then now the same thing for Alice, starting at, well, I don't need all that. Same for Alice, starting at 0. Okay, so far so good. Let's keep going and see where this takes us. Test full garden. We have a full garden. All right, Alice should be happy. Bob Charlie. All right. How many kids is this? Okay, this is a lot. and because I noticed down here that we have that this list of students is actually dynamic, and so I can't implement methods. I mean, I guess, the very naive implementation of this would be to create well, I don't even know if that would work. I don't even think it would work to just create in order to create method names for like every possible student name, or even just a really, really good list. That's still not going to solve your problem, because you have this you have this variable here for the column, the starting column. And I guess you could take whatever you were passed in, this dynamic list of students, and use that to calculate it. But if you're going to do that, why not just make the whole thing dynamic? And so let me do that now. So let's see. So method missing, if you never used it before, you've probably heard of metaprogramming in Ruby. And this is one of the things. This is one of the tools that you can use in order to do metaprogramming. Which metaprogramming, the kind of basic definition you hear people give is metaprogramming is code that writes other code. And that's sort of what we're doing here. We're not really writing code. We're basic, but we're creating message handlers that don't really exist as code. So if you've heard me talk about this before, you may know this, that in object-oriented languages, technically we're not calling methods on classes or on instances of classes. We're sending them messages. And this is made explicit in Ruby with this method missing method that we can implement here. The default implementation just passes it on up the chain, and it'll you'll get an error if you try to call something that doesn't exist. And in fact, we can watch that happen here with who's the next kid here, David. Sorry, David, you don't exist in our classroom. And so we get an undefined method, David. But what method missing will do is give you a way to handle that, to intercept it and say, oh, you know what? I do know what to do with this. And so the signature allows you to take a method name, which will be a symbol, and then our arguments, and then a block. But we don't need all that. All we care about is the method name. And we want to do something if we know who this student is. I'm going to call it, because method name, it's method name there. That's what you're given, but that's not super clear to me. Student name is what I'm interested in. And what I want to do is call super unless I know who this student is. And so I'm going to pretend I've got a list of students. And then if I do have it, I'm going to call planters from column for that student. And so remember what I said a second ago, that I could take the list and find the offset. So let me just brute force this real quick. I want students index of student name times 2, because there are two cups per student in each row. So I want to, for each kid in the list, I want to move over 2 to get their starting column. Now, of course, students doesn't exist here. So I'm just going to write a method here for the moment, students, which will have, will have an array of symbols starting with Alice, Bob, Charlie, and now David. And so let me just see if this works as I've written it now. Yeah, it did. And so because of that, I can get rid of these existing methods. Okay, there's a lot of kids in this class. I'm just going to go ahead and do a bunch of these here. Let's see. All right. Eve, Fred, Ginny, Harriet, Ileana, Joseph, and I'll add Kincaid since I can see Kincaid. Okay. And Larry is the last one. So let's see if all these kids work, all these students. There we go. Yes. Okay. Disordered test. Okay, the names are not in alphabetical order, so we're gonna have to sort these on the way in. This is just the setup, so that's not gonna do anything. But wrong number of arguments. Oh, okay. So our initialize method needs to accept an optional second argument, students. So I want these to be my default students. Students equals default students. And I'll set an instance variable. And now I need an adder reader because I deleted my students method. And I want an adder reader to use the instance variable here. Okay. So I think this will fail because I need to sort those. Oh, you know what? Undefined method Patricia. They gave us names. I need to do a couple things here. I need to take this list of students, which is a list of words. I need to downcase them, and I need to convert them to symbols. Okay. I also need to sort. All right. Roger. Samantha. And Xander. All right, let's keep going. So 2 gardens with different students. Same diagram with different students. Why? Okay, I think that's going to work. All right, all the tests are passing, and let me do just maybe a little bit of refactoring here. All right, I got a magic number here. So planters from column. So this, what I want this to be is students.index student. So I want the index of the student times the, let's call it the offset. Per student, or this, how about the student offset? And I'll add that up here at the top. Student offset equals 2. I see another one right here. It's also a 2. Planters for column row, but you know what? It's not the student offset. This is the student planter per row count, right? Student planter per row count. And notice, even though these are both the same number, I'm using different constants because the concept is different, right? Here it represents the offset per student. Here it represents the number of planters that they get, which, even though the offset is 2 because the student planter row count is 2, in each of these spots they're fulfilling a different function. They mean something different. And so I don't want to duplicate I don't want to use the same one, because it would only make sense in one spot. But actually, it does make sense. I realize now that I said the student offset is 2 because the student planter row count is 2, is I could just do that. Because they should be in sync. They need to be the same, but conceptually they're different. Similar to how I called this method name here because method missing, that makes sense as the argument name. But I don't care that it's method name in here. I care that it's the student name. So that's what I change it to. And then one other thing here, I feel like this is doing too much. Planters from column. Method missing needs to call planters from column, but here it's also determining the start index, or the start column. The start column for given student. So let's see what that will be. Start column for a student. And let me get rid of that. So I've isolated that bit of knowledge, start column for student, to its own method. And I think that's done. Let me go ahead and submit it. All right, well, thanks for watching. Thanks for sticking through this far. I hope you got something out of it. And if you did find this valuable, if you got something out of this, please click the like button below. It really helps with the YouTube algorithm and people being able to find these videos. And subscribe if you'd like to keep up with what I'm doing. And also, if you want a deeper dive into how to refactor, how to write code today that you won't hate in 6 months, how to become a hero to your team, be sure to check out my tactical refactoring video course, which I've linked below. All right, have a great day, and I'll see you in the next video.